In the Clean Sky 2 ACCLAIM project, new installation techniques were developed and validated to optimize the lining installation processes for airplanes. The focus of the project lies on an automated assembly, human-robot collaboration, as well as newly designed aircraft parts and a mock-up fuselage section which are ready for automation. An automated guided vehicle, short AGV, identifies the carrier type through a QR code. After aligning, it automatically docks itself to the carrier. AGV and lift communicate with each other and exchange location and floor data in order to take the load to the desired lining area. The AGV and the part carriers are designed to meet requirements of limited access and load capacity inside the aircraft. An integrated vision system scans the side panel and identifies the best position for gripping and assembly. The panel itself is held by self-locking fixtures on the fuselage structure. A digital twin with a dashboard software enables monitoring of the whole process from a remote workstation. For the assembly of the hat rack, the robot assists the worker by lifting and installing the heavy load. The instructions for the correct assembly are provided to the worker by a HoloLens using augmented reality. The robots are designed to operate even in the cargo section of the aircraft. This can avoid the ergonomically unfavorable postures of the workers in the confined area. The vision system identifies the gripping position, and the trajectory is planned to avoid all possible collisions in the confined cargo space. The validation of the processes yielded positive results in terms of productivity, ergonomics, and costs. The developed solution is a potential alternative to conventional assembly methods for future aircraft cabin and cargo installation.